All right, let's jump into Geometry Basics 5. Now, the main reason why this lesson exists, we're going to talk about different types of angles, different names that we can give it, and the names are actually important here. Even if you don't like vocabulary, it's important to know these names because when you know the name, then you know what to do with it based on the name because there are certain properties that hold true. So, for instance, we're talking about starting with adjacent angles. Now, when you think adjacent, if you live adjacent to somebody, that means you live next to them. So that same idea is going to hold true here. There's going to be one common side and a common vertex. So adjacent angles would be the ones that are next to each other. So for instance, when we look at angles 1 and 2, that would be examples of adjacent angles. We could actually say the same thing about angle 2 and angle 3. Now, what you should notice about those angles, they don't actually share any interior. So there are no points that are inside both of the adjacent angles. Okay. So, for instance, if you were to look at a big angle, and then it was broken up into two little ones, you wouldn't be able to say that the little one and the big one were adjacent. It doesn't count if one is inside the other. Okay. All right, let's get to number 2. Now, this term comes up maybe more than anything else I have ever seen in geometry class. Pretty much every day, every week, there's something that relates to vertical angles. Okay, now, when you find vertical angles, the sides are opposite rays. Now, when we hear opposite rays, in the last couple of units, couple of lessons, we talked about how opposite rays make a line. So in this case, when you look, we have, let's look at angle 1, for example, okay? So the rays that are forming angle 1 are here and here. The opposite rays to that are here and here, which means angle 3 would be a vertical angle with angle 1. Okay, so the sides are opposite rays, so angle 1 and angle 3 would count as vertical angles. Now, this is really important because vertical angles are congruent. So if you ever read a word problem that's talking about vertical angles, you will know that that means the two angles that we're talking about are equal, so you could then put them equal to each other. So that is really important. Now, one last thing you need to know about vertical angles. Don't let the name fool you. Just because they're not looking vertical, that doesn't mean we wouldn't call them that. So usually kids ask me at that point, oh, well, is there such thing as horizontal angles? Well, no, we still call them vertical angles. Even though 2 and 4 sort of look horizontal from each other, the point is still the same. They are still going to be congruent. They're still going to be called vertical angles, even though you don't necessarily think of them as vertical. Well, they don't look vertical. That doesn't really have anything to do with it. The name vertical angles has nothing to do with whether or not they are actually vertical. All right, so next we're going to get into complementary and supplementary. Now, teachers have different ways of telling their kids how to remember telling these apart. The difference is complementary angles add up to 90 degrees. Supplementary angles add up to 180 degrees. Now, that would mean in this case, the complementary angles in the picture on the right, I would say angle 4 and angle 5 would be complementary because they add up to 90. Whereas if you looked maybe angles 1 and 2, those would be examples of angles that add up to 180 because you have 90 degrees and you have 90 degrees again. So you have two right angles. To me, C comes before S in alphabetical order. 90 comes before 180 numerically. So I don't spend a ton of time worrying about that. Some teachers may have come up with some creative things And if they did and you remember that without me, that is amazing. I'm happy about that. All right, let's go to the next one, which is a linear pair. And this would be two adjacent angles, so it has to be next door neighbors, and the non-common sides are opposite rays. Okay. So again, that would be something like 1 and 2, because if you look, they were both formed from the same line. So we have a line here, the one I'm going to highlight in red, and then from that line, we took that line, we broke up that straight angle into two separate angles. That would be angles 1 and 2. So whenever that happens, you've created a linear pair. It's a pair of angles that were formed from the same line. And again, when you see opposite rays, you got to think line. Now, because they were formed from a line, and a line is 180 degrees, that means all linear pairs are automatically supplementary. So now we get back into that word again. Okay. So hopefully those pictures help you out a little bit. We're just going to do two examples relating to that, and then we are going to stop for the day. So let's go through here. Angles 1 and 2 are vertical angles. So what is x? What is angle 1? What is angle 2? Now we just got done talking about it. Vertical angles are always congruent to each other. So if we know they're going to be the same, then we could put them equal to each other. So that's what we're going to do. We're going to just turn this into a regular equation. 3x plus 1 equals x plus 43. So then from there, we're just going to knock this out really quick, and it's going to turn into a two-step equation from here. Okay, and I'm not going to spend a ton of time going over what I'm doing here because we are basically just doing algebra, so I know you have better things to do with your time than worry about that, but we do have 2x left over here. We have 42 left over here. Cut that in half, and you find out that x equals 21. So when we list out exactly what's going on, we do want to describe both angles as well. So x equals 21, but then now, while we're at it, we should plug that number in so that we can discuss what the measure of angle 1 is and what the measure of angle 2 is. So over here, 3 times 21, I'm going to go up and plug it in, is 63 plus 1 is 64 degrees. And if we did it right, and you could actually plug it in to check, if we did it right, angle 2 should be the same thing because they are vertical angles. If you wanted to plug in and check, you'd put 21 up here. 21 plus 43 is 64. So we are good. All right, let's step up our game a little bit. Angles 1 and 2 are complementary. 2 and 3 are supplementary, but they only give us 1 and 2. So let's start with what we know. We know that 1 and 2 are complementary, and the definition of complementary is that if you add them up, they should add up to 90. So that's what I'm going to do here. I'm going to say that the part plus the part is the whole thing, kind of like what we did with segments and angles before. So this part plus this part adds up to give you 90. So that makes pretty good sense. We'll combine like terms and we'll get this thing done really quick. 6x plus 36 equals 90. At this point, you would subtract 36 from both sides. So 6x equals 54, which means x equals 9. Now this is where we're going to want to really be careful about plugging things in because we have a lot going on here. We actually have 3 angles going on. So the measure of angle 1 is x plus 9. So we know that x is 9. 9 plus 9 is 18 degrees. Now there are 2 different ways we could figure out angle 2. We could either say, hey, these add up to 90, and we could subtract 18 to see how much is left over, or we could plug it in right here. Either way, you will get the exact same answer. 5 times 9 is 45, plus 27 is 72. Either way, no matter how you would have looked at it, you would have been able to come up with that. Now, the last thing, now we have angle 3, and it's easy to forget angle 3 because I never gave you any information about it. But it's still there. We still have to figure it out, and angles 2 and 3 are supplementary, which means if I took angle 2, which is 72, and then I added it to angle 3, you would get 180. So from here, you could call it y, you could call it x, you could use some algebra interpretation, or you could just sort of use common sense at this point, and I don't want to tell you no on the common sense part. We know that angle 2 is 72. We know they need to add up to 180 total. So no matter how you look at it, we're going to subtract 72 to figure out what is left over. And it turns out the measure of angle 3 is going to be 108 degrees. So I hope this helps you get a jump start on lesson number 5. Get to work on everything else you have, and I will talk to you all later.